Name is Nick, and this is a video about finding the derivatives of logarithms. So this is my first video on this channel. I'm a high school student who has a great interest in math overall, but so far I've only taken classes up to and including Calculus 1. So these short videos that I'm making purely out of interest and just as a passion project, we'll only cover up to Calculus 1 topics. Not only calculus, this first video just happens to be because it came to my mind, but other videos could be anything relating from statistics to even geometry if I feel like it. I'll keep, as you could see in the name, easy math. I'm going to keep it very simple, nothing too crazy, but whatever topics I feel are interesting. My next video will likely be calculus, maybe statistics, but there's not much else to say, so let's get right into it. So we're starting off here with d dx of e to the u equals e to the u times du dx. This is our starting point for today because we're going to be using this to help find the derivatives of both the natural log and logarithms of other bases as well. So let's start with a function y equals ln of x. If you're not familiar with what this graph looks like, if we just look at the first and fourth quadrants here, it sort of has a shape like this. Very poorly drawn, but you kind of get the point here. There's a vertical asymptote at x equals 0, and the domain is from 0 to infinity, where 0 is not included. So that's sort of, well, what we're looking at here. So let's take the derivative of both sides here. Let me actually show how we get to that point. Sorry. With the property of, let's start with property of logs. The two properties of logs that we're going to be using in this video are as follows. It would be helpful if I show these. If we have log a of b equals c, then a to the c equals b. So what you could kind of visualize this as, there you go. So this is a property of logs I will be using very shortly. I was going to jump right into it, but I figured I should go over this first. Let me get rid of that arrow. And also, what's known as a change of base formula. So if we have log base a of b is equal to, let's just say, ln of b over ln of a. But this really applies to any base. So this could be log base 2 of b, log base 2 of a, or whatever. But that's we're going to be sticking to ln. This is going to be useful for what we're doing today. So let's start with taking the derivative of this equals what? So let's grow up. So if we have y equals ln of x, this can also be written, you don't see it written like this, but we'll log base e to the x. So if we do that little arrow notion there, let's do that. We'll have e to the y equals x. And now once we take the derivatives of both sides, we have e to the y dy dx equals 1. So now if we divide both sides by e to the y, we're going to have dy dx equals 1 over e to the y. And we stated up here that e to the y equals x. So we could put that down there now. And so we'll finally have dy dx equals 1 over x. So that was a nice way to find the derivative of ln x without having to use a cumbersome definition. Go by definition. It's possible to do it that way as well, but to keep it concise. Now let's consider a logarithm of base a of x. Now if we take the approach we did before, we'll have a to the y equals x. And then what's the derivative of a to the y? Well, do you want to do that by definition? I'm assuming that we don't know that here. So let's scrap that. Let's do something else. By something else, we also introduce this property up here, change of base. So I'll use a different color here to highlight that's what we're using here. Use red. kind of sloppy, but it's my first video. Cut me some slack. um, so y is also going to be equal to ln of x over ln of a. And now we can find the derivative. Ln of a is just a constant, so we can pull that out. That's not going to affect anything here. As we stated before, ln of x, the derivative is 1 over x. So dy dx here equals 1 over x ln a. I don't know why I chose to use this color, but if we go back to our original color here, let me see. I was using blue. There you go. So there you go. That was a nice and easy way to find the derivative of a logarithm of any base, not just our natural log over here. So I think that's all I wanted to cover. We're already hitting like 6 minutes, but just for the fun of it, let's try to find that derivative of a to the y. I know I said we'd mostly keep it to logarithm. I'm going to use orange now. Scroll up. So let's say we have y equals a to the x. Now, with our newfound knowledge, we could read, well, I wouldn't say newfound knowledge. Let's take the natural log of both sides. Ln of y equals ln of a to the x. Okay, we're going to have to introduce another property of logs I wasn't going to talk about previously. But if we have something else, if we have a log base a of b to the power of c, you can, I'll use the arrow to show what we're doing here, bring that exponent down to the front. And so it's going to be equivalent to c log base a of b. And this also works the other way as well. You can put it back up if you wanted to. So that's another property of logs that I won't care to prove here. But that's what we're going to be doing here. Show ln of y equals x ln of a. So if we take the derivative of both sides, we're going to have 1 over y dy dx by implicit differentiation, which is a topic for another video, equal ln of a. So dy dx equals y ln a. So there you go. Pretty cool. So that's just a couple of basic derivatives of logarithms, how to find them. It's nice to just know these by hand, but I feel like it's good to know where these come from because, I mean, I feel like we're born out of the womb knowing, oh yeah, the derivative of ln x, 1 over x, there you go, easy. But you don't really think about where that comes from, so that's why I felt the need to make this video, to show that where these came from. I mean, taking derivative of logs, at least in calculus 1, was pretty uncommon, I feel like. But I felt like using the change of base formula is not something you do every day. So couldn't pass that chance. Hitting about 8 minutes now. So I think that's it. Thank you for watching this video. This was first video of Easy Math with Nick. I'll be making more videos like this very soon, so thank you.